Okay, let me discard this. Okay, so forward power control, that is for forward motoring. So Q1 and Q2 is turned on to give us this circuit here. Yeah, everything else is off. And this happens for time KT, and VL is this polarity, and EG, well, I call it EA or EG, it's this polarity. You call them a screen too? Okay, good, you'll send me that. V, VA is VS, right? Then, then for time 1 minus K multiplied by T, that is 1 minus K in brackets times T, we can leave either Q2 on and Q1 off, or we can leave Q1 on and Q2 off. Let's leave Q2 on and take off Q1. And when we leave Q2 on and take off Q1, we get this circuit. And let me draw back. And the inductor voltage will flip. The magnetic field of the inductor is being charged now. No, sorry. We're not charging nothing. The inductor voltage is flipping to maintain IA in the armature circuit. Then Q1 will turn back on again and current will be supplied to the machine again via Q1 and Q2, as in this blue color here. Right? I forward power control. Then for regeneration now. So Q1, Q2 and Q3 are turned off, and Q4 turned on alone to give us, why is this right? Give us this circuit. This is your current here. This is EG, and this is VL here. IA rises now, and the magnetic field of the armature inductance will store some of the kinetic energy of the armature. And then Q4 is turned off. Or let me erase all this now. Q4 is turned off, and then remember, right, this was our EG. When Q4 is turned off, the inductor voltage will flip to this polarity to forward, and the sum of VL and EG will be greater than VS. So to forward bias these two diodes to send current back through the source like this. And this is your IA here. Okay, now we have to move on to reverse power control. In reverse power control, Q3 and Q4 are turned on to give us this circuit. And this is your current here. This is your EG. This is your VL. And the armature is turning. And then Q3 is turned off and Q4 is turned on. So let's draw that. When Q3 is turned off and Q4 is turned on, this happens. Get this circuit now, and this was original EG. Armature is still turning, but then the inductor voltage will flip to this now to maintain IA in the circuit. And this happens for time 1 minus kt. I forgot to mention the time for when Q3 and Q4 were on, that happens for time kt. And the same kind of thing for regeneration too. The first circuit state was kt, the next circuit state is 1 minus kt. The same for forward power control. First circuit state is kt, second circuit state is 1 minus kt. This is right, reverse power control. Right. So that is it for reverse power control. Then we have, right, well, right, so after this happens, Q3 will be turned back on and the current will be supplied to the machine again via Q3 and Q4. And that is the end of reverse power control. Now we need reverse regeneration. In this, Q1, Q3, and Q4 are all turned off. But everything is turned off and the armature is rotating. Then Q2 is turned on. Remember the armature voltage was, sorry, the armature voltage was, I had it wrong in my right up here. The armature voltage was this, right? And then when Q2 is turned on, current will flow through here to build up this. IA will rise to as the inductor magnetic field increases to store some of the kinetic energy in the armature. Let me correct that in my write-up here. Okay, and then Q2 is turned off. The inductor voltage flips to this. I don't like how this thing draws, but anyhow. Q2 is turned off. Inductor voltage flips to this polarity. Oh, sorry. To this polarity, right? Inductor voltage flips to this polarity, and the sum of VL and EG is greater than VS, which forward biases D3 and D4 to send current back to the source and through the armature circuit again. And this Right, this second state happens for time 1 minus kt, 1 minus kt, and the first state with this, the red was kt, and that is the end of reverse regeneration.